Hello everyone, come join me as we go through the 30-day LeetCode challenge. So basically, since everyone's staying at home during quarantine, LeetCode has put out this challenge for everyone to take. So we're going to be walking through the first 5 days. Alright, let's see. Let's go to week 1, and let's start off with single number. The language I'll be using is JavaScript. Alright, it's already set that way. So let's see the question. So given a num-empty array of integers, every element appears twice except for one. Find that single one. Your algorithm should have a linear runtime complexity. Can you implement it without using extra memory? So I have some notes that I did before this, and I have solved it without using extra memory, but it's a bit long. So we're going to go on Replit. So let's take this test case and we're going to put it into Replit. So let's go through it. So function single number. Just setting up the function. So we want to show the element that does not repeat. So in this case it would be 4. Alright, so let's see. Alright, so the first thing we can do is sort the array. Use ES6. Let's double check it. Alright, so now let's loop through it. Alright, so now we can do if array at index I is not equal to. So now, if I is equal to 0, we want to return array at index I. Else, if array at index I plus 1, oh sorry, I minus 1, is not equal to array at index I, and we want to return array at index I. So now if we run this, okay, sorry, typo, there we go, and we get 4. So let's input this into the function, and let's see our results. Okay, we're going to change sums to array. Nice. Let's submit it. Alright, fast. Next one, happy number. So write a number to determine if a number is happy. A happy number is a number defined by the following processes. Starting with any positive integer, replace the number by the sum of the squares of its digits, and repeat the process until the number equals 1, where it will stay, or it loops endlessly in a cycle which does not include 1, whose numbers for which these process ends are in 1 are happy numbers. So basically we're going to take an input and then split it, and then each individual number will keep squaring, and then add them together and then get a new input. Bring it back down, split it, square each individual number until it's down to 1s and 0s. And if the number is equal to 1, return true. It's a happy number. Else, false. So we're going to create an algorithm for that. For now, this was the one that I was testing out. Let's just leave that out for now. Well, we can leave it here. And we can take it to Replit and start from scratch. So let's make that function. Oops, sorry. And the input is going to be an integer, so just 19. And we're going to call that num. So we're going to let current equals to num. And then we're going to make a new set. So we're going to let scene equals to a new set. This is for the end product. And then what we're going to do is we're going to loop through it. While current is not equal to 1. Okay. And let sum equal 0. And then we're going to do another loop inside this while loop. While current is not equal to 0. We're going to keep looping through it. Then we're going to do sum is equal to current modulus 10. By doing this, grabs the number 9 itself. It slices the last number. Like, slice doesn't work with numbers, so this is the way to kind of slice that. So current modulus 10. And then we have to increase it, or else it's always going to be 9. So then we're going to do current is equal to current divided by 10. We have to use math.floor, or else we're going to get decimal numbers. Okay, put those two. Then we're going to do an if statement. If scene has sum and then return false. And then we're going to do scene.add. If it hasn't seen it, add the sum to it. And then we're going to keep moving number along, or else it's going to stop itself. So we're going to do current is equal to sum, and then we're going to return true, because if it hasn't seen it, just return true, and that would be 1. Whoops, typo. There we go. There we go. So 19. So let's run this in our. So basically, if it doesn't equal to 1, keep doing this, and this will always loop through each individual number. And if it has seen it, just return false. And if it hasn't seen it, add it to the set until it returns true. So if we run this, it should pass the test case. Yes. And submit. Alright, so that's happy number, not a maximum subarray. Just ignore that for now. So given an integer array nums, find a contiguous subarray containing at least one number, which has a larger sum, and return its sum. So basically, if we have all these numbers, we want to find the largest sum between all these numbers. It can be random. So let's take it to Replit. Okay, so we're going to do max sub. Function max sub. Okay, and then let's put the data in. let sum equal to 0, and then let max equals array at index 0. So we don't know what's the maximum will be, so we're always going to make it the first element by default until we can look through the array's elements and find a max from there. But for now, starting initially, it's going to be the first index, the first element in the array. Alright, so now that we have that set up, we're going to look through the array. Okay, so now max is now going to change, and we're going to be using math.max to find the highest sum of the number. So we're going to do math.max sum plus equals to array at index I, and then max. So basically it's the same. Is the addition of the current array at index I and into sum higher? If it's not, put in the current max as the highest. And then sum is going to do the same thing. Math.max sum or 0. And then we'll return max. So in this case it's 6. So let's go back here. And our output is 6. So let's run code. And it finished. Now let's see if it passes the test cases. Accepted. Nice. Alright, move zeros. Given an array of nums, write a function that moves all zeros to the end of it while maintaining relative order of the non-zero elements. You must do this in place without making a copy of the array. So we can't use like array.map to make a copy of it or make a new array. We just have to mutate the array directly and minimize the total number of operations, so the least amount of steps. So kind of let's do this again from scratch in Replit. So we're gonna do move zeros. And we're going to take our test case, and we want all the zeros to the right hand side. In this case, we want to have a helper function. So what we want to do is we want to look through it, and then from there have a helper function that swaps it. And that way we can swap all the numbers and then push all the zeros to the end. Alright, so we're going to look through it, and if it doesn't equal 0, swap it to push all the numbers to the end. So let's do that right now. So we're going to do let index equal 0, and then we're going to do a for loop to get access to each element in the array. Okay, well, let's create the helper function. Let's leave that for now. Write the helper function down here. And the helper function is going to take the array and I and j index. So I'm going to let temporary equal to array at index I, because we want to grab that first index. Just hold that place, and then we're going to reassign it. It's going to be assigned to array at index j, and then array at index j is going to take the variable temporary. Just kind of swapping things around temporarily until we get everything the way we want. Now, if array index I is not equal to 0, then we want the helper function to do its job. Swap. We're going to pass in the array. We're going to pass in the index variable, which is 0, and then we're going to pass in I. And then we have the increment index So it's able to move through the function, the helper function. So index plus plus. And then we're going to want to return our array. And there we go. So our helper function is what swaps everything for us as we pass in the values. Let's see if it runs. Nice, finished. Okay. And the last one. Say you have an array with the elements of the price given on the stock on day I. Design an algorithm to find the maximum profit. You may complete as many transactions as you like. Buy one and sell one share of the stock multiple times. You may not engage in multiple transactions at a time. You must sell stock and sell the stock before you buy again. So you can't constantly buy. You have to buy, sell until you get the best value you can get at the output. So in this input, we have the array here. So we buy on day 2, which is right here, price of 1, and sell on day 3, price of 5. The profit, 5 minus 1 is 4. But we can't buy an initial day. And then we buy on day 4, right here, price is 3, and sell on day 5, 3, and which is price 6. And the profit is 6 minus 3 is 3. So the best day to buy, like our highest output, would be 7. But over here, if we buy on day 1, price is 1. If we sell on day 5, the price is 5. And our profit is 4. Oh, sorry. Up here is 4 plus 3. That would be our best profit. So note that you cannot buy on day 1, but buy on day 2 and sell them later. As you are engaging in multiple transactions at a time, you must sell before buying again. So that's it. 4 would be the best here. In this case, no transaction is done. Max profit is 0. Alright, so let's begin. Whoop. So this is called stock. Let's call this stock. Okay, stock. We're going to pass in the data. We want our output to be 7. What I want to do is get access to each of these elements. So let's look through it. Array index I is less than array index I minus 1. Keep going. Else max profit. Oops, forget to create a variable here. Max profit plus equals array at index I minus array index I minus 1. Return max profit. Oops. There we go. Missing a semicolon. Sorry guys, because I was supposed to start one step ahead of the array. Starting at 0 is what caused the issues. So now 7. So let's go back here and run it. I see. Alright, so it passed the test, and for now I'm going to stop here, and thank you for joining me on these LeetCode challenges. I plan to go through the rest of these as time goes on, and we'll include group anagrams soon. All right, thank you. Take care.